All right, factoring out a GCF, greatest common factor. Okay. If you'll remember, a greatest common factor is the biggest number that goes into everything. For variables, it's the exponent that they all have. Okay. So let's say we've got 16x cubed y squared plus Alright, I'm just looking to get a GCF. That's all I want to get out of this is the greatest common factor.
This is on the ACT, right?
Yes, it is. It is on ACT. Alright, what's the biggest number that goes into both 16 and 36? 6 doesn't go into 16. 8. 8 doesn't go into 36.
9, 4.
4. 4. 4. Okay. Now what about variables? They both have an x and they both have a y, right? So if I'm going to take out x's, what? 3. Why 3?
So 16 has 3x and 36 has 3x.
Okay, right. See, this one is to the third and this one is to the fourth. But I can get 3 out of both. I can't get 4 out of that one because it doesn't have 4. Okay? So it's going to be 16x to the third. What about the y? Y. So if I divide this by 4x to the third y, what's left? 4. 16 divided by 4 is 4. If I divide this by 4x to the third y, what's left? 9. X. That's your answer. If you're just going for a GCF, that's it. That's your answer. Okay? So I'll put you in greatest common factor. What?
Is this how they're going to be, or they're going to get a lot more complicated?
They're going to get more complicated. Alright. Try this one. I will tell you, it just has a GCF. There's nothing else that you have to do. Try that one. It just has a GCF. Don't do anything else to it. Alright, what's the GCF? 2x. 2x. What does that leave me with?
X.
Yes. Very good. Good. Okay. I'm going to add a term. Oh, yeah.
Doing 3? Not doing it.
Alright, what's the GCF here?
3x.
3x. So what's this going to be? X squared. What's 4x? Minus 12. Okay. Does everyone see how we got from the red to the blue?
You get x squared.
3x cubed divided by 3x. The 3's cancel out. X cubed divided by x is x squared. Alright, anybody else? I'm not erasing it, we're doing more to it. What? It's all part of my ego. Okay, what, does anybody remember what this part right here is called with that x squared right there? What this is called with an x squared? What's something with an x squared? It's a quadratic, and we know how to factor quadratics.
Depressed polynomial.
It is a depressed polynomial.
That's why I was
Two numbers that multiply to equal negative 12 and add to equal 4. 6 and negative 2. Alright, now don't forget your 3x. Don't forget your 3x, but I'm going to focus just on the middle part for a minute. So I'm going to rewrite this as x squared plus 6x minus 2x minus 12.
Huh? What? What?
Replace your 4x with the 6x minus 2x. This is quadratic factoring. We did this about
3 weeks ago.
3 or 4 weeks ago. Yep. So what can I take out of the front? X. And I'm left with, nope,
X plus.
yes. What can I take out of this back part? Negative 2. Why is it important that it's a negative 2 and not just 2? Alright, so why is it important that it's a negative and not just 2? What has to happen with this set of parentheses and that set of parentheses? They'd be the same. And if I don't take out a negative 2, they're not going to be the same. Alright, so those are exactly the same. What's my answer?
3
X minus 2 and X plus 6.
Okay.
Huh?
X minus 2 and X plus 6. And don't forget that 3x that we took out to begin with.
Okay, so I have a question.
Yes.
When do you have to do that? You have to do it on every problem.
If it's a quadratic, you need to see if it factors. Yes. If it has an x squared or anything squared, 2x squared, 6x squared, 9x squared, whatever, if there's an x squared in that problem, you need to see if it factors further.
That's one thing that we were last week. Common factor.
What one thing?
Now we have a 0. Zero factor.
We're getting to that. We're going to put it all together. But we got to do this first. Alright, let me give you one to try. Okay? Alright, you can try this one. X cubed. There is a GCF. That GCF is going to leave you with a quadratic that you need to factor further. Okay. What's the GCF? 3x. That's right. So that leaves me with x squared minus x minus 2. So when I go over here, I'm going to ignore the 3x for just a minute and just focus on the quadratic. When I go over here, what goes in the top?
Negative 2.
Negative 2. This is what this number times this number is. So 1 times negative 2 is negative 2. What goes in the bottom? Negative 1. That's the number that's right here. Well, there's not a number right here. Yaha. What is it? 1. We just don't have to write it because we know if there's 1x there, then that means there's 1x there. Right?
So there's 1 and 2.
Okay. So I need numbers that multiply to equal negative 2 and add to equal negative 1. Negative 2 and a positive 1. Yes. Okay, so I come over here and I'm going to rewrite this using that negative 2 and positive 1. Don't forget the x's because it's not just negative 2 plus 1. It's negative 2x plus 1x. If you forget the x's, then you've actually changed the value of the function. And we're not allowed to change the value, just the look. We can change how it looks, but we can't change what it's worth. Okay? Nope. It really doesn't. Alright, so let me do this. What can I take out of the front end? X. And that leaves me with what?
X minus 2.
Yes. Now, there's nothing that I can take out of the back end, but I got to do something. So what number can I divide by that doesn't change it? 1. I'm going to write plus 1. Because if I divide by 1, it's still going to be x minus 2. What's the answer from just this part?
X plus 1 and X minus 2.
Yes. And then, don't forget, you've already taken out a 3x, so bring it down. Right there. That's your answer. Good. I'm making you one more of those to try, and then I'm gonna show you a different kind of example. One more of those. You got it?
Body? Yeah, that's what I was saying.
Because you have to take out something, right? And x and -2 don't have a common factor. So you have to do something. So what can you divide by that's not going to change them? Well, I can divide by 1. So I divided by 1 and it was x, and I divided by 1 and it's -2. Here, the outside becomes its own little thing. So that's how we got the x plus 1. Yeah. Okay? Alright, try this one. 10x squared minus 50x minus 60. Okay, so what was the GCF? 10, okay. X squared minus 5x minus 6. So I go over here.
Put -6 up top and
-5 on top.
Alright,
negative
-6.
-1.
Use -6 for 1.
Exactly. Okay. So that's going to be
Squared minus 6x minus 1x
not minus 1x,
plus 1x.
plus 1x.
Plus 1x minus 6.
Yes. And here I can take out x.
So -6 and 1 is taking a slot of the -5.
I got a 1.
Right, because what's -6 plus 1? Exactly. So see, I didn't change anything, just how it looks. Okay, and then plus 1 right here. So that's x plus 1, x minus 6. Bring down the 10. That's it. Now the next thing that I'm going to show you is pretty easy because it looks just like this. It's called factoring by grouping. And you'll have 4 terms, 1, 2, 3, 4, that you just go right to grouping them together and factor. Problem here is when you're done, sometimes you're not done, so that's always really fun. Let me show you what I'm talking about. Okay? X squared, no, x cubed plus 3x cubed. Okay, so I have 4 terms. I'm going to factor by grouping. I'm going to group those 4 terms together. Okay? This one, this one. What can I take out of the front group?
X cubed
No,
squared.
x squared. X squared. And I'm left with x plus 3. What can I take out of the second group? Nope.
Oh no.
-1. And I'm left with x plus 3. Okay, see how this is exactly the same as the other stuff up to this point?
That's awesome.
Yeah, it's fantastic. Now, here's what you need to know. Just like the other one, these two have to match. So if they don't match, you've done something wrong. You gotta do it again, okay? But that leaves us with x squared minus 1, x plus 3. On the last set of problems, we'd be like, done, walk away. But what's that? It's a square. It's a quadratic. It's a quadratic with no x term. Basically, this is x squared plus 0x minus 1. Can you think of 2 numbers that multiply to equal -1 and add to equal 0? 1 and -1, right? Okay, so you think you're done. You're not done. Now you're done. Now you're done. That's it. Now you're done. If you get down here to a quadratic, you have to see if it factors. You have to check it for factor.
How did you get X?
Because there's no x term, right? What's the x term here? 0. So I'm looking at this. I needed to multiply to equal -1 and add to equal 0. Well, that's -1 and +1. That's it. Okay? This one actually is special. Right here. It's called difference of two squares. X squared is a square. 1 is a square, because 1 times 1 is 1. Anytime you have a difference of two squares, it factors down to plus, minus, every time, those square roots. What's a perfect square number? 9, okay, so 9 x squared minus, what's another perfect square number? 16, okay. So, see, this is a perfect square, 3x. This is a perfect square, 4. You factor this, it's going to go to 3x plus 4, 3x minus 4. Every time. So keep a lookout on those. They'll save you some time. They can be huge numbers, like 121 x squared minus, I don't know, like 169. That's square root is 11x. That square root is 13. It's going to be 11x plus 13. 11x minus 13.
So basically, you just write both ways.
Exactly. It's such a shortcut. And it's a shortcut that works. Okay? It works. Notice how they're kind of, remember when we did conjugates? It's the same number, but with opposite signs in the middle. That's why there's no x term. It gets rid of the x term when you multiply them together, because they're conjugates. Okay? Alright, let me give you one like this to try. You're going to group it, and then you're going to factor. Okay? And make sure, if you think you're done, that you're actually done. Okay? X to the third. No, that's not right. It's minus x plus 4. Sorry. So let's group. What can I take out of the front group? Alright, what about this last group? So I have x squared minus 1, x minus 4. Am I finished?
No, we have to wrap it
Right.
across.
Right there, I could say x minus 1, x plus 1, x minus 4.
No, you're not.
Something that you need to make sure you notice, okay? This is called the difference of two squares. What's a difference? A subtraction problem. Subtraction. This, that is not a difference of two squares. That actually doesn't even factor over real numbers. That has an imaginary answer. Okay? If it was this, okay, yeah, x plus 5, x minus 5. This, no.
So we just do it
Okay.
like that then?
Like, you can just leave it.
Alright.
Yeah. Yeah. Right. Alright, look at those pages that you tore out.